Straight line graphs. Here we have a simple grid from -5 to 5, and we have a straight line that is drawn on the grid. So, what can we say about these lines? Well, there is an intercept, and specifically, it is the y-intercept. It's right here. So where the line crosses the y-axis, this is the y-axis, this is the x-axis. Where it crosses the y-axis here, we call that the intercept. So right here, we call that the intercept. Okay, and we also have something else we can take from this line. So we could have really shallow lines, we could have lines going facing down. This one happens to be facing up. We measure that and we call it the gradient or the slope. And what we do to figure out the gradient or the slope is we calculate rise over run. So what does that mean? If I pick a point, right here is a convenient one because it's right here at -3, -3. The rise is how much this value goes up, and the run is how much this value goes over. So if we look at this, the gradient or the slope equals rise over run. And in this case, we could calculate it. We can also call this the slope of the line. So the rise in this case is 1, 2, we're going up 2. And the run in this case, we're going right 1, so that's a positive 1. So the slope in this case would actually be 2. So from any straight line, we can get the intercept, where it crosses the y-axis, and the gradient or the slope, which is rise over run. Okay, now, let's draw a graph with a given equation. So here is an equation of a straight line, y equals 2x plus 3. And we want to graph this. So the simplest way is to make a table of values. So we will do that right here. And we will choose the x value, that's independent. And the y value is dependent on what we choose because y equals something here with an equation. So for instance, let's pick a number. Let's start with something like, let's say -3. Okay, we'll look at -3. Okay, so what that means is we're going to take this equation and put -3 in here for x. So we have 2 times -3 plus 3. So that's -6 plus 3. That's -3. So when x is -3, y is -3. And that is a coordinate pair. That can be graphed right here, -3, -3. That point is right there. And that is one point on the line. And we're going to continue to do this with several other values. And I'm arbitrarily choosing these. So let's try -1. Okay, so what that means is -1 will go in here. So 2 times -1 plus 3. That's -2 plus 3. So we have +1. So when x is -1, y equals 1. And -1 and 1 is right here. So there's another point on the line. Let's do another one. Let's try +2. I'll write this down here because I know I'm going to do another one in between. +2 means x is 2, so 2 times 2 plus 3, that's 4 plus 3, we get 7. So when x is 2, y is 7, but that's off our graph, which is why I left it over here. So let's get one more point so that we can join these. Although for a straight line, you really only need 2 points. So if we had a ruler and we could fill this in, we'd have a nice straight line. But let's have 3 just to be thorough. So I left the gap in there to try number 1. So when x is 1, we have 2 times 1 plus 3. That's 2 plus 3, and we get the value 5. So when x is 1, y is 5, and we can plot that as 1 and 5. All right, so there we go. We have 3 points. They're all in a straight line, and so now I will join these as best I can to make, there we go, the graph for the equation y equals 2x plus 3. So to do that, you make a table of values, you choose some points for x, you find out what y is, you plot the points, and then you can join with a straight line. Let's calculate the gradient of these lines. So these are already given, and we said gradient is the same as slope, and the equation is rise over run. So we're going to calculate rise over run for these 4 straight lines. Okay, so we can start anywhere where there's an intersection. Anywhere we have, and we'll also assume that each one of these lines represents 1. So we can start right here, and we can just go up 1 and over 1 if we want to. Or we could go up 3 and over 3. This one's quite simple because it crosses at every box. But you'll see with other ones that we'll have to count different amounts. But so here we go. So rise is 1, and then run is 1. Both of these are in the positive direction. So when we're going up and when we're going to the right, these are positive. Of course, when we're going left and down, those would be negative. So in this case, the gradient or the slope equals rise over run. So for A, we have 1 over 1, and that simplifies to just 1. So the slope there is just 1. Now let's look at B. Let's start here, okay? So if we go up 1, then we're here, which is in between. We're not totally sure what this is. It's probably a half, but try to always find lines that cross, points where it crosses. So there's 1. Okay, so we go up 2 and over 1. So in this case, rise over run will be 2 over 1, and we can simplify that to 2. C. Okay, let's pick a point that crosses here, and then let's make this one nice and large just for illustration. As long as you find a point that crosses, you can get your slope. You can get your gradient. So to go from here to here, we need to move up 3. So our rise is 3. And we need to move over, I'll have to count those, 1, 2, 3, 4, 5, 6. So 3 over 6 can be simplified to 1/2. So I did a large one here just for illustration, but we could have simply gone up 1 and over 2, and that would also given us 1 over 2, which is 1/2. Or we could have gone up 2 over 4. That would give us 2 over 4, which is 1/2. Or we could have gone from this point all the way over to this point. And the point is that the rise over run will always simplify to give you the same ratio, the same value. So as long as you find where the line crosses, like here and here, then you'll be fine. Okay, D. In this case, we're going to start right here at the beginning, and then we'll go right to the end. So what's important here is that you're always moving to the right, and when we do so, this one's now pointed down. See, these were all pointed up. This one is pointed down. So our rise actually goes down. 1, 2, 3, 4, 5, 6 units. So we write that as -6. We're going down. And then our run is still positive. It is 2. -6 over 2, and that simplifies to -3. So in this case, our slope or our gradient is negative. Okay, now let's determine the equation of this line. We're given a line. It's on a grid. We have our x and y axes. It crosses, so we're going to need to find, yes, the slope like we did in the last question, but also the intercept. Okay, so an equation of a straight line is y equals mx plus b. Or sometimes you'll see this as c or z or another value. The point is that this is the slope or the gradient, and this right here is the y-intercept. Y and x, those are the variables. So those stay y and x, but we need to find the slope and we need to find the intercept. So let's do the slope first. So let's find where it crosses nicely. Let's say right here. And then we'll go up and over to this one here. So slope, or the gradient, equals rise over run. And in this case, our rise is 2, positive 2. Our run is 1, positive 1. So rise over run is 2 over 1, and that is simply 2. Okay, our y-intercept, which I will abbreviate there, y-int, is where this line crosses the y-axis. Here's the y-axis, the vertical axis, so it crosses right here. And that is at -1. So our y-intercept is -1. So now we need to put this number and this number into our general equation here. So y equals, m in this case is our slope, and that's 2. So y equals 2x, and then b is our intercept. In this case, it's -1, so we write 2x minus 1. So the equation for this line right here is y equals 2x minus 1.